Hi friends, Monday is the day to release the stamina accumulated after a relaxing weekend. This question seems suitable to be discussed on Monday. You can read this question for a while. Maybe you don't really understand this question. There's no harm in watching this short animation. We see a block leaning against a wall. The height of the block and the wall are the same. Right above the contact surface, there is a cylinder. Not long after that, the block shifts to the left at a constant speed. Of course, the cylinder above it will be affected. The cylinder moves in such a way that the surface of the cylinder always touches the wall and the block. At one point, the block and the wall are separated by a distance of the square root of 2 centimeters. Now, we are asked to calculate the magnitude of the normal force exerted by the wall on the cylinder. I think this is quite a difficult question. Whatever it is, let's discuss it. The image on the screen is a snapshot of the motion of the cylinder as seen in the previous animation. The radius of the cylinder is r. The distance between points A and B is square root of 2 centimeters. Since the radius of the cylinder is 1 centimeter, how about we just write the distance as our square root of 2? One more thing, the speed of the block is v. It seems that this is the only value listed on the question sheet. We are asked to calculate the normal force acting on the cylinder. So our focus of attention now is the cylinder. The normal force is perpendicular to the contact surface. Since the contact surface is a point, we will play an animation of the cylinder's motion. From this we know that the normal direction is from the point of contact towards the center of the cylinder. This is the force we want to calculate. Take a look at this animation again. Do you notice anything? That's right, the point of contact is the axis of rotation. The cylinder is rotating about the point of contact. An object that rotates is caused by the centripetal force. What are the forces acting on the cylinder? The cylinder is around the Earth, there is a downward force of gravity. The cylinder is also touching the block, there is a normal force N2. We give different indices to the normal force, to distinguish between the two normal forces. It seems that this is the only force acting on the cylinder. All of these forces cannot be added directly. We need to decompose the force into component vectors. Let's think of the central angle as theta. The components of the gravity force are mg cosine theta and mg sine theta. Mathematically, mg cosine theta minus n1 is equal to mu squared over r. The force towards the center of rotation has a positive sign. What about n2? For this we need to be a little careful. Geometrically, the center point of the cylinder must be in the middle of the distance between the wall and the block. Because the block and the wall have the same height. This is true, isn't it? Thus, this length is half r root 2. The sine of theta is equal to half r root 2 over r. We can cross out the value of r. Theta is 45 degrees. The angle next to it is also 45 degrees. Because both angles are symmetrical. From here we know that n2 and mg sine theta are in the direction perpendicular to the centripetal force. The force in this direction has no effect on the centripetal force. In this equation there is a quantity u. What is this speed? U is the tangential velocity of the center of mass of the cylinder. Look at this animation. The tangential velocity is always tangent to the path. The speed is perpendicular to the normal force N1. This is true. In the condition of the problem, the direction of U is in line with the force N2. We know that the center of mass of the cylinder is always in the middle of the distance separating the wall and the block. This means that the displacement of the center of mass of the cylinder in the horizontal direction is always half the displacement of the block. In other words, the horizontal component of the velocity of the center of mass of the cylinder is half v. Let's examine the horizontal component of the cylinder in terms of its tangential velocity. The velocity U can also be decomposed into its component vectors. From this we know that U cosine theta is equal to half v. Isn't the cosine of theta half root 2? From this, U is equal to v over root 2. We already know the values of U and cosine theta. Just substitute these two values into the original equation. This equation can be written as follows. Now we will look at some values on the problem sheet. Using a scientific calculator, N1 is about 4.9 newtons. You will get different answers when using different values of acceleration due to gravity. Happy learning, everyone!